Hey Opties! Today we're going to be talking about linear inequalities. An inequality is when you're not equal, but you're less than or equal to, greater than or equal to. And we're going to be taking linear functions and translating them to be a linear inequality instead. Let's take a look and see what it looks like when you're graphing a less than or equal to. First, we have less than. Notice we have this symbol here to represent less than. This symbol only works in this particular direction if your y or your function notation, such as f of x, is on the left. Here's what I mean by that. This is equivalent to this y is less than because you swapped the sign and the location of y. The part that is closed is pointing towards the y, so that's the less than. Same thing over here. The part that's closed on that V looking symbol, which is less than, is right next to the y. So both of these mean less than, and this also means less than, but only with the function notation of f of x. So either of these mean the same thing. But typically we have our y or f of x on the left-hand side of the equation. That's not always true. The y values that exist for the function are strictly below the bound of the line. Now, strictly is a very important word here because the strictly is where we get this dotted line, the dotted function line. So how you would graph an inequality that's less than is you would graph the function but make it dotted, and then you would shade below the line because y is less than. And think about it, your y-axis is vertical. So if y is less than, you're going towards the negative y's or the smaller y's. So that's why you're shading below. Now let's consider a less than or equal to. So if y or f of x is on the left, then it looks like a less than symbol with a line underneath, where the extra line underneath is the part that will tell us or equal to. It can also look like this. Your y is on the right, so your symbol swaps direction, or if your f of x is on the right. So the y values exist for the function itself, so a full line, so the function itself exists for all the y values, and below that. So you notice the difference between this picture and this picture is that for the less than, it's dotted, and for the less than or equal to, it's full. So if you have an or equal to portion of your inequality, then that will give you a full line for when you're graphing, so a solid function line. Let's look at our point to ponder. So it says the graphs make sense from the point of view of the y values being less than or equal to, than that of the function. So always solve your inequality for y/f of x before graphing. So this is referencing what we're talking about when you can swap the direction of your inequality if your y or f of x is on the right. So if you're wanting to think about how it's graphed, the easiest way is to solve for your y or f of x and have it on the left, and it just makes it a little bit easier to think about. You don't have to do that, but it's advised. It will probably be helpful to you. Now let's look at greater than. So the greater than symbol looks like an opening to the left, and how that would change if your y or f of x was on the right is it would be the same idea where it swaps. So it could look like this or this. So the y values exist strictly above. So notice that a less than or greater than, they both have a dotted function line. But the greater than would be above and the less than would be below. Looking at the greater than or equal to, which could also look like this, we see that we have a solid line. Just like the less than or equal to, we have a solid line. So the solid line comes from the or equal to part, and it's shaded above, and that part comes from the greater than. So it exists for the function itself, all the y values, and for everything that's greater than the y. So it's a solid function line. Here's another point to ponder. The inequality is written as if y or f of x is on the left. So if y is on the right, the sign swaps. So that's what we've been talking about in blue here. You can solve for y on the left to view the original notation for the signs. So typically when we say greater than or equal to, it looks like this symbol. So if you want to view it as that symbol, you need to solve for your y or f of x and have it on the left-hand side. Let's take a look at some linear inequalities practice. So first we have less than. We're going to graph the linear inequality on the graph below. So notice our y is on the right. It's probably easiest to think about if we solve this inequality for y. So let's do that. Let's add 8 to both sides. So now 6x plus 8 is greater than negative 2y. Now, we haven't mentioned this yet, but remember, probably back from Algebra 1 or maybe even in middle school, that if you divide or multiply by a negative, your inequality swaps direction. So let's make sure we do that. Negative 2 divided by 2 is 1, so we'll have 1y over here, and now we're swapping direction. 6 divided by negative 2 is negative 3, so that's a negative 3x, and 8 divided by negative 2 is a negative 4. So finally, to make it a little easier to think about, let's make the y be on the left, and make sure the opening is towards the y still. So we swap the y and the inequality symbol. When I say swap here, I mean when we're moving the y to the left-hand side, not the literal swap of the meaning that we did do for dividing by a negative. So now we have negative 3x plus 4 on this side. Now let's graph it. This is a slope-intercept form, but just with an inequality. So let's plot our y-intercept first. 1, 2, 3, 4. Then we will use our slope of negative 3 to find another point, and then we'll go from there. So negative 3 would be down 3, right 1. You could go up 3, left 1, but that's kind of off the graph. So let's just stick with these 2 points. Now, there is no or equal to piece, so this needs to be a dotted line. Y is greater than, so you're going to be shading above. I like to just kind of do some lines to show my shading, because if I start coloring, then I'm going to be really making a mess of my graph. Number 2 is, so far it's looking like a less than or equal to. So let's take a look. Graph the linear inequality on the graph below. So let's solve this one for y as well. It's almost there. We just need to divide both sides by 4. So 2x divided by 4 would be 1/2 x. And 12 divided by 4 would be a positive 3. And we didn't divide by a negative, so we're keeping the same symbol, like the same direction. And now to make it a little easier to think about, let's make the y on the left-hand side. Keep the closed up part towards the y. So it's still y is less than. This also means less than, or not less than, but just less than or equal to, right? Because we've got this bar underneath to show the or equal to. And then we've got 1/2 x plus 3. So let's graph the 2 points to start drawing our line. Plus 3. And that's because that's our y-intercept. And we'll do 1/2. Up 1 over 2. This has an or equal to, so it will be a solid line. So it looks something like that. And it's a less than, so we're shading below. Again, this is me showing shading. It's nice to do this because later on, and you might have done this before actually, maybe in Algebra 1, if you have more than one inequality, let's say we had one like this, and we wanted to shade that one, and we didn't have 2 colors, we could do this, and then we could see the double shaded. and we'd see the solution to the system of inequalities. So there's an example as to why I like to do those lines that are perpendicular to my function. Now we're looking at some greater than practice. Number 3, graph the linear inequality on the graph below. Let's solve for y. So we'll divide both sides by 3. 21x divided by 3 is 7x. And negative 3 divided by 3 is negative 1. We did not multiply or divide by negative, so our inequality symbol stays the same. And 3 divided by 3 is 1, so it's just a y. Now let's rewrite for y to be on the left. And graph our 2 points. So we'll start with our y-intercept. And then we'll use our slope. 1, 2, 3, 4, 5, 6, 7, and then write 1. There is no or equal to, so it's a dotted line. And it's greater than, so we're shading above. I do want to point something out. It looked like this number 1 over here was a less than. It's in the less than column. But we did end up changing the symbol because of dividing by negative. So it really was truly a greater than. But that's why it was in the less than column, because it originally looked that way. Let's look at number 4. Graph the linear inequality on the graph below. Let's solve for y. So we'll add 6 to both sides. We have negative 5x plus 6 is less than or equal to 15y. Now let's divide both sides by 15. Negative 5x divided by 15 is negative 1/3 x, and then positive 6 divided by 15. Take out a 3 in each and you get 2/5. And we didn't multiply or divide by negative, so the symbol stays the same, and we have a y. Let's finish it by putting y on the left. Negative 1/3 x plus 2/5. 2/5 looks like somewhere around here. It's not quite 1, right? But it's less than half. And then we go down 1, right 3 for our slope. This is an or equal to, so it's a solid line. And it's a greater than, so we're shading above. All right, that's it for our linear inequalities. See y'all next time.